As recently as the 1980s, scientists believed a child's brain at birth was fairly static, largely predetermined by genetics. Researchers now know that's not true. While genetics clearly play a role, scientists know that relationships and experiences shape the brain. Think of a developing brain like a multi-storied house under construction. In this chapter, we'll explore the basics of brain development and help you understand how early traumatic experiences can design a different house. When we're born, our brains are teeming with more than 100 billion neurons or brain cells. Under optimal conditions, when our needs are met consistently by nurturing caregivers,
You got a red ball.
our brains thrive. These neurons connect in complex and vast networks, much like the electrical wiring in a modern home.
The baby comes with all this wiring, but it's the human interaction. Looking into the eyes, being held, hearing the song of my mother, feeling the strong shoulder of my daddy, that begin to make the brain develop in very, very important ways for all of the life skills that will come.
At birth, the lower floors, or the downstairs part of the brain, is firmly wired in place by genetics, allowing a child to breathe, eat, sleep, and hear. Survival functions are rooted here. Very few connections in the upper floors are formed. These more sophisticated parts of the brain govern higher functions: complex thought, reasoning, emotional processing, memory, speech, and most importantly, the ability to regulate our behavior. It takes time and repeated experiences for this circuitry to develop and become hardwired in the brain. When a child experiences trauma, abuse, neglect, or other risk factors, it can skew the wiring of the brain, as well as the structure and the chemistry. The lower, more primitive survival part of the brain can overdevelop from reacting to fear, while the critical upper floors may underdevelop and suffer.
In the book that I wrote with Dan Siegel, The Whole Brain Child, we talk about an upstairs brain and a downstairs brain. For some kids,
Dr. Bryson is a psychotherapist at Pediatric and Adolescent Psychology Associates, Director of Parenting Education for the Mindsight Institute in California, and best-selling author along with Mindsight Executive Director Dr. Dan Siegel.
the upstairs brain is the more sophisticated part of the brain. It's our cortex that takes a long, long time to develop. And it's the part of the brain that allows us to regulate our emotions and calm down our bodies, understand ourselves, understand other people, and really be able to make good choices and be flexible and adaptive. The downstairs brain is much more primitive. It's actually really well developed at birth, and it's the limbic area and the brainstem connected to the body. And that part of the brain is much more reactive, and its job is to kind of constantly be watching for how to keep us alive.
Dr. Bryson's research and studies in attachment science, child-rearing theory, and interpersonal neurobiology have made her a sought-after expert contributor with appearances on Good Morning America, PBS, and Red Book magazine. She says trauma triggers the watchdog part of the lower brain, called the amygdala, to work overtime.
And its job is to constantly sort of scan the environment, to be paranoid a little bit, to be watching, is everything okay here? Am I okay? Am I safe? Is anyone out to get me? Can I relax? And that part of the brain is always appraising what's going on around us, reading faces, reading the environment.
Do you like bubblegum?
Yeah.
No.
When children feel threatened or overwhelmed with fear, they may fight, run away, or shut down. The brain kicks into survival response, which researchers called fight, flight, or freeze survival mode. If the brain stays in this state too long because of trauma, it reorganizes around survival at the expense of healthy development of other parts of the brain.
So for a child who's had repeated exposure to fearful experiences, whether those be sort of a trauma like a car accident, or whether it's developmental or relational trauma, where the caregiver was frightening or they were left for long periods of time to manage their own fear states. The downstairs brain has gotten a lot of practice being active. It's the repeated experiences that we have that actually activate growth and connection in the brain. So if a child has had a lot of experiences where their downstairs brain that was reactive and fearful, that part of the brain gets really well developed. Whereas then the upstairs brain that knows how to calm that fear and kind of do that self-soothing, like, oh, that was a scary noise, but I'm okay now. That part of the brain may not be as well developed in children who have had repeated fearful experiences.
The impact goes beyond the upper and lower floors. The fear and stress of trauma also affect the left and right hemispheres of the brain, which help coordinate logic and emotion.
The left brain specializes in logical, literal, linear, and linguistic, which is using words, in those modes of processing information and going about in the world. The right hemisphere, on the other hand, is much more closely connected to emotion, to sensations in our bodies, to kind of looking at the whole picture as opposed to bits and pieces, and more random ways of processing information as opposed to linear. And the important part is that they work together as a coordinated whole. When children are in situations where their needs are not responded to, where their emotional states are not understood, or there is not a caregiver who responds consistently, quickly, and in an attuned way, the right hemisphere does not get nurtured. It doesn't get developed optimally. So when one side takes over, we can either be cut off from our emotions or we can become flooded by them.
It's not just our emotional balance that gets upset by trauma. It also disturbs the delicate balance between our brain chemistry and the hormones that drive our central nervous system and our entire being. In times of stress, our bodies produce the hormone cortisol, revving our bodies to a state of high alert. Periodic stress and short bursts of cortisol actually stimulate growth and help us adapt and change. When stress stays too high for too long, toxic levels of cortisol become corrosive and can lead to a host of long-term problems. Rockefeller University neuroscience professor Dr. Bruce McEwen is noted for his pioneering work on the impact of stress on the brain.
In a chronic stress situation, our lab has shown that dendrites in some parts of the brain, like the prefrontal cortex and the hippocampus, will shrink and communication will be impaired.
Most critically, Dr. McEwen says chronic stress takes a heavy toll on the vital front part of the brain that controls emotion, memory, and attention.
The prefrontal cortex is very vulnerable, and when there is chaos in a child's life, lack of good attachment, development of the prefrontal cortex is severely affected. And it's involved in the downstream control of everything that's going on, whether it's impulsivity, whether it's aggression, anxiety. It helps control mood. It helps a person make decisions when to stop something, to do something else. It's the brain area that is so important for self-regulation, which is so important for success in everything that we do as adults.
Dr. McEwen is a best-selling author, former president of the Society for Neuroscience, and expert contributor for the PBS series This Emotional Life.
Early life adversity and toxic stress is often associated with increased frequency of disorders like obesity, diabetes, cardiovascular disease, as well as brain problems such as substance abuse, antisocial behavior, depression.
When a child stays in elevated states of stress, that cortisol stress hormone washes over the brain and washes through their body. And we know that brains that are exposed to chronic cortisol look different from healthy brains.
And I'm wondering if we can outline the paper.
Doctors Karen Purvis and David Cross have conducted extensive testing on children who have experienced early harm. They've found severe imbalances in cortisol and neurotransmitters. Neurotransmitters are the chemical messengers the brain sends the body. Some excite and some calm, and trauma can dramatically upset the balance.
A young child who is getting optimal care has a balance in the brain chemistry. The chemicals about I'm afraid, I'm hungry, I'm cold, those are called excitatory. are balanced when the caregiver comes and gives warmth. And then the chemicals about I'm safe, I'm fed, I'm loved, we call those inhibitory, come into play. And so this child has excitatory but then inhibitory. So there's a balance in the brain chemistry. If a child has early trauma or harm, even brief early trauma or harm, these systems become imbalanced so that I'm afraid, I'm hungry, I'm scared, I'm lonely. Takes precedence. And there's very little of what would come when the needs were met. For children that we have seen over the years, and we've done neurotransmitter tests to test the level of this chemistry on more than 2,500 children. And what we find is dramatic levels of excitatory neurotransmitters, dopamine, beta-phenylethylamine, norepinephrine. We find glutamate that causes seizures very high in many of the children.
And research shows these imbalances also raise the risk for mental health issues and lots of behavioral issues. The takeaway message is this: trauma damages the brain, especially a young developing brain. It alters brain structure and upsets the delicate balance of brain chemistry that drives behavior. It puts a child at risk for a lifetime of problems.
I'm sorry.
But if you know the risk factors that predispose a child to harm, you'll be in a better position to quickly intervene and minimize the damage. Up next, key risk factors. Some may surprise you.